Okay, on page 105, talk about density. Okay, we are going to, our objective today is to evaluate real life situations using density and volume. As a reminder, I said I would talk about how to find the cube root in your calculator. Okay, so if we're solving something like 16 times 4, 32, 64. Okay, if I want to find the cube root of 64, how would I do that in my calculator? So I have an older calculator here, but you can still see how it works. If I want to find the cube root of 64, I'd go to math, clear. I'd go to 3, because that's the cube I want, or the root I want to take, the third root. Math, down to 5, and then of 64, it would tell me 4. So the notation for this is 3, math, 5, and then whatever you're taking the cube root of, so the number. In this case, it was 64. Okay, that will take the cube root for you. All right, so today we need to talk about density. And what density is its mass over volume. Okay. So we can also talk about population density. And it's very similar. That's population divided by volume. Okay. And in volume, we can also talk about this in terms of area. So if I was like looking on a map, let's say I had a map, and in the map was this little, say this was my map, and this was country A. And all these dots represented people. And I wanted to know the population density of this country. I would first find the area. So it's 4 by 1, 2, 3, 4, 5. Times 5. So the area is 9. And the number of people are all these little dots. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 dots. Okay. So squared units. So if I want to find the population density of this country, it would be the population, which is 9 dots per 9 squared units, or approximately 1 dot per squared unit. Okay, so this is the formula that we're going to be using, and it might get a little bit more confusing. We might have some more intricacies to it. So let's take the problem. A pillow costs $0.05 per ounce. Okay, the density of the pillow is we'll say 1 gram per centimeter cubed. It's a pretty dense pillow, about as dense as water. Okay, it's 1 gram per centimeter cubed. the pillow can be modeled by a rectangular prism. How much does the pillow cost? And let's say my rectangular prism is this. And we'll say this is 4 by 3 by 10 centimeters. Okay, so they want me to find the price of the pillow. So I first need to find the volume of the pillow. So the volume of the pillow will be length times width times height. Okay, so the volume will be 10 times 3 times 4. So the volume is 120 centimeters cubed. Now I need to find the weight of the pillow. How much does the pillow weigh? So I know that density equals mass over volume. I know the density is 1, and the mass, I don't know, and the volume is 120 centimeters cubed. So gram per cm cubed. So when I cross multiply this, I have 1 gram per centimeter cubed times 120 centimeters cubed equals my weight. My units cancel, and I'm left with 120 grams is my weight. Oh, I should change this, sorry. 5 cents per gram. Okay, so they want to know how much does a pillow cost. Well, I know it's 5 cents per gram, so they want to know the cost. Well, the cost will end up being 5 cents per gram, so $0.05 per gram. And I want my cost to be in dollars, so I'd have to multiply by the number of grams. My units cancel. And 5 times 120 is about $6. Yeah, $6. So the cost of this pillow is $6. Okay, so this is how we might use density in a problem. They might ask you to find the density of something, so you'd have to figure out the mass and the volume to determine the density. There's a whole bunch of different ways we can go about doing this, but this is pretty much what we'll be using in our density problems.